So guys, as you can see, these are our LEDs, and this over here, this one is the button I am going to use. So let me press the button. See that after every 1 second, one LED turns on. So there are total 7 LEDs. See. So for a button being pressed for 1 second, it means one LED on, like one task being done. So now I will press the button for 3 seconds. 3 LED will turn on. Then I will release it. See what happens. 1, 2, 3. I release it. See, it turns off. Now I will press the button for 5 seconds. 1, 2, 3, 4, 5, and I release the LED button. They turn off. So for as long as the button is pressed, for every 1 second, one LED turn on. So this one LED represents one task. So in other applications, you will replace the LEDs with the tasks being performed. So guys, hello guys, welcome to learning microcontrollers. In this video, I'm going to show you how you can use single momentary push buttons press time to do various tasks using PIC16F877A microcontroller. So we will be using 7 LEDs on a single port, and then I will be using a momentary push button. When I will press the button, after every 1 second of being pressed, one LED will turn on. As soon as I release the button, the point at which LED was to be turned on, like after 4 seconds, if I release the button, only 4 LEDs will be on, and as soon as I release the button, the LEDs will turn off. All the LEDs will turn off. That's how you can perform various tasks. So instead of task, I'm going to use the LEDs for demonstration purpose. Later on, you can derive various applications. So let's get started. So guys, this is our PIC16F877A microcontroller having 40 pins. It's a DIP version. Guys, these are the 7 LEDs I'm going to use here. So guys, I will be using a port B for the LEDs. Each LED has 2 pins, one longer, one shorter. Longer is always the power and shorter is the ground. For the shorter pin, that is the ground pin, common them and send them to the common ground of the PIC like this. Now for the longer pin, you will need a 220 ohm resistor. This is a safety resistor. You can use other values as well depending upon the required brightness of the LED. But I am going to use the 220. So we start from the bottom LED, connect the longer pin to the one end of the 220 ohm resistor like this. Now from the other end of this 220 ohm resistor, you can connect it to any available digital input output pin of your PIC. I am going to use the pin number B0. Then for the second last LED, do the same, longer pin to the resistor. Then from the other end of the resistor, use any digital input output pin. I am going to use the pin number B1. For the third last LED, connect the longer pin to the one end of the 220 ohm resistor like this. Then from the other end of the 220 ohm resistor, you can connect it to any available digital input output pin. I'm going to use pin number B2 like this. Now for the third LED from the top, connect the longer pin to the one end of the 220 ohm resistor like this. Then from the other end of the 220 ohm resistor, connect it to any available digital input output pin. I'm going to use the pin number B3. Do the same for the third LED from the top, connect it to the one end of the 220 ohm resistor like this, the longer pin. And then from the other end of the 220 ohm resistor, connect it to any available digital input output pin of the PIC. I'm going to use the pin number B4. Now for the second LED from the top, do the same. I connect it to the B5 and the topmost to the B6 like this. In this way, our 7 LEDs are connected to the port B. Now for the button, this is a momentary push button, easily available in the market, very cheap. So you can use other type of momentary push buttons as well, no issue. Now this push button has 2 pins. Both are the same. This is a non-polar component. You can shuffle these 2 pins as well. I named the one on the left as VCC, other on the right as the signal pin. You can shuffle them, like you can make the left one the signal, right one the VCC. It doesn't matter. So now guys, you connect the VCC pin directly with the VCC pin of the PIC like this. Now for the signal pin, you will need a 10 kilo ohm resistor. You connect the signal pin to the one end of the 10 kilo ohm resistor like this. Now from the same pin, you will take out your output. For the output, you can use any available digital input output pin of the PIC. I'm going to use the pin number D1 like this. Now guys, from the other end of this 10 kilo ohm resistor, connected to the common ground like this. In this way, our LEDs are connected and our button is connected. So let's get to the hardware. So guys, this is the hardware over here. These are the 7 LEDs. And this push button I'm going to use here, this one. This one is a push button I will use. Okay. And this over here is a PIC16F877A microcontroller. So let's get to the programming. So you can see the PIC better here. This is the PIC16F877A microcontroller. How to set up this hardware? I will share the link of a video in which I taught you how you can set up the hardware. In the description of this video, there will be a link. You can open that link and you can learn how to set up the hardware as well. So let's get to the programming. So guys, this is a MikroC For PIC. Let me zoom in so you guys can see better. This is the MikroC For PIC version 7.2.0 I am using here. You can use the latest version as well. Latest is always better. Click on File, New Project. This window pops up, New Project Wizard. Click on Next. Write the name of the project. I write button based tasking by using press time tutorial by learning microcontrollers. This is the name of the project I wrote, and this is the path where the code file will be stored. This is the microcontroller. I'm going to use a PIC16F877A, and this over here is a crystal connected to the pin number 13 and 14 of your PIC16F877A. So I have a 20 megahertz crystal over there, so I'm going to use the 20 megahertz value over here as well. Click on Next and Finish. Now guys, this window pops up. Press Ctrl S to save your work before you do anything else. Right now guys, first of all we initialize the button pin, that is TRISB equals to 1. It is like a pin board command in the Arduino. TRISB.F1 is the name of the pin, TRIS is the register, 1 means input, 0 means output. Initially the button must be at 0 because our grounding resistor over here. Let me tell you how you can verify what the button is gonna send. Either it will send 1 or 0. This depends upon this 10 kilo ohm resistor. If this resistor is at the grounding end, it means a 1 will be sent whenever the button is pressed. If this resistor was at the VCC end, then this means that a 0 will be sent whenever the button is pressed. So in this configuration, a 1 will be sent. So initially our button pin should be 0 because 1 will be sent when the button will be pressed. So by default it must be 0. And now give some initialization delay. 100 will do fine. This is not necessary, but I always suggest you give it in the one-time loop. Now for the LED, declare the complete port B as output because we have LEDs on the port B. 0 cross 0 0. This will send 8 zeros to the LED port, that is port B. So all the pins will be turned as output. And for the initial state, initially the LEDs must be off. So we give whole port B equals to 0 cross 0 0 in hex. That complete port B is now off by default. I mean the LEDs at port B are off. All the pins are at 0. So 1 means LED on, 0 means LED off. Now we have our LEDs initialized, we have our button initialized. Let's get to the forever loop, right? While 1 forever loop starts here, ends here, and inside it start doing the programming. So I write if the button is pressed, port D.F1 equals to 1 like this, and now we will give a debouncing delay over here once only. So I write if the button is pressed and I give a debouncing delay. This delay is only there in case the button is accidentally pressed by any phenomena like a dust particle or anything, so it should not trigger. So if the button is pressed and it is still pressed for more than 20 milliseconds like this, then what it should do, give two ending brackets. So in the end we should not forget them how many we have to give. So it will turn on the first LED. I turn on the LED port B.F0 equals to 1. The first LED is on, and for how long? For 1 second. It's on for 1 second like this. Now guys, if we write other condition, if still the button is pressed, copy this, place it here. Now if still the button is pressed at the third ending bracket, then copy this, okay, give the semicolon. Now this is our first task. If the button is being pressed, then the first LED turns on without any delay, no timing here, or you can give it a delay as well, like make it a 1 second. So whatever you want to do, you can do with the code. So if the first button first LED will turn on as soon as the button is pressed, then the LED will remain on for 1 second, and if still the button is pressed, even after 1 second the button is pressed, the second LED turns on at B.F1, that is pin number B1, pin number 34 of the PIC, like this. Then what should happen? Now it will still check if still the button is pressed. Okay, if still the button is pressed, then okay, if I write here like this, and then for the third LED, copy this like this, like this. Now if still the button is pressed, then the LED at B2 will turn on like this. Now again look for the fourth time for the pressing of button. Now we check for the next condition. If still the button is pressed like this, then make it look presentable. Just follow the same sequence, so it will be easy to debug if there are errors. Now again copy this, paste it here. Now if still the button is pressed, check for the brackets. You should not miss any bracket. So we had missed one bracket, add a bracket here. So if still the button is pressed, make it F3. The fourth LED turns on. Similarly, keep doing it until you want your tasks are completed. Now you paste it here, paste the ending bracket here. Again, look, make it look presentable. This will be good for you for debugging purpose. Okay. Now the fifth LED turns on if still the button is pressed for after 1000 seconds. Now again do the same. Copy this, place it here, ending bracket like this. Now if still the button is pressed, then the sixth LED turns on like this. Now if still the button is pressed for more than 1 second, after 1 second, now again the seventh LED will turn on. Like after every 1 second, if the button is still pressed, it will keep turning on LEDs. See, the next LED turns on, give the ending bracket. Now before you do anything else, this LED is at B6 like this. Now what is going to happen here is that if the button is pressed, it will look for the debouncing delay. If the button is pressed for more than 20 milliseconds, it means that the button is pressed by a human hand. Then it will turn on first LED for 1 second. And after 1 second, if still the button is pressed, it will turn on the next LED for 1 more second. And if still the button is pressed, it will turn on the next LED. Like after every 1 second, it will keep turning on the button. But suppose you have turned on this LED, now you release the finger, then it will turn off all the LEDs. So we need the else loop for that. So this is our first bracket, recheck the brackets. So this is the first bracket, fine. Second bracket, fine. Third bracket, it's fine. Fourth bracket, it's fine. Fifth, it's fine. Sixth, it's fine. And then we have seventh, it's fine. And then we have the eighth. Okay, it's fine. All the brackets are fine. Okay, now the next thing is what we do is that we give the else here, right? Else if the button is not pressed, then all the LEDs must be off. So for that we go to the initial state of the port B, that is this state over here. Go down, place it here. So all the LEDs are off by default. Again the default state will be met. So we build the code, no errors. Now we go to the programming tool. Let's burn it, click on file. This button based tasking, click on write. Okay, the new code is being written. Let's get to the hardware and see what happens. So this is our hardware over here. Okay, this LED is connected to B7. B7 is a PGM pin, so it will blink whenever the programming is taking place. Okay, this is a good sign. By default, no LED is on. So that's what we did. So see, after every 1 second, it turns on one LED. See, now all the LEDs on. I release the button. They turn on. They turn off all the LEDs. Now take a look here. 1, 2, 3. I release the button. See, all are off. See, 1, 2, 3, 4, 5. I release the button. All are off. So LEDs will keep on turning on by counting the timing of our button being pressed. See, 6, 7. All are on. But I remove the finger. They go to the default state. Again, take a look. 1, 2, 3, 4, 5. I release the button. They are off. Now I will turn on 3 LEDs. 1, 2, 3. Release it, off. So I will give you this code in the description of the videos, guys. And you can play with the code. So if you have any questions, you can ask in the comment section. Thank you very much for your time, guys. For me, it is a great obligation if you guys learn something from my video. So thanks for your patience and have a nice day.